Right, re tlo lebelela reactions of alkenes. So now let's form. So Tomoka 1. Okay. Right, so level more. An alkene is an unsaturated. You know that is an unsaturated molecule because of the double bonds between the carbon atoms. So level more. The bond between carbon atoms here, there are two. So if there are two bonds, then we're going to say we have an alkene. So now an alkene always undergoes an addition reaction. So this one is an addition, and then another addition, addition, and addition. So if we have an alkene reaction and then with something else, then it means we're going to have a we're going to have an addition. Then we'll look at the type of additions. So what level an alkene here, which is an ethene. And then we add that to chlorine gas, which is Cl2. That's why it's now Cl bonded to another Cl. So Cl is group number 7. So Cl A1 always my short 1 bond. So that's why Cl minus. So here they bonded together, and then now they are going to react. So then there will be a one bond that is going to break here. So that's why when I allow one bond, then one bond and then now it will accommodate Cl bakamuka. So now all the carbons dinale single bonds, and then there are 4 bonds between each carbon. So the condition for this is just need an unreactive resolvent. So if a reaction condition of a alkene versus halogen, then we'll say we need an unreactive solvent. Type of reaction, because this Cl is from halogens, which is group number 7, then reclonoring is halogenation. Halogenation or edile only the halogen group, which is the one that are group number 7. So the reactions always be an alkene. So alkene be double bonds, a molecular double bonds between carbon atoms. Maybe recover C bonded to C bonded to C, and then maybe double bond here. Then here or over hydrogen, so that at effective 1, 2, 3, 4, or more hydrogen, then hydrogen, hydrogen, and hydrogen. So this is an alkene. We can over as long as we want a double bond between two carbon atoms, then it's fine. We're going to say that okay, that alkene it will react. Now react alone, abangodile X2. What this X representing? It can represent normally chlorine and bromine. So abashimisha jona je chlorine and bromine. So ora ke jona je tlo reactor mo. Then if you're edile jona fail, or the reaction over the product will be haloalkane. Haloalkane means robale an alkane. Why alkane? Because it breaks the double bond to a single bond. That's why we call it an alkane. Then halo is mix only the halogens. So halogens here, that's why the product will be haloalkane. Then the name, of course, we can have 2-chloro ethane. So we'll get the name is later, but this is what is happening. So this one can also be added to Br bonded to Br. Then of course now it produce something else, but we'll talk about this one. We'll talk about this one here. Right, let's get to this one again. Let's call this number 2. So on this number 2, we still have an alkene, which is an ethene here. And then now re-add the 2 hydrogens, which is H2, and then now they produce an alkane here. So if re na le alkene ra adda hydrogens ya produce the alkene. Now the reaction condition e ka mo re ka shumisha platinum ke yona itumeleng or the nickel as a catalyst, so to speed up the reaction. And then types of reaction we say are hydrogenation, the type of addition reaction. Ka baka la hydrogenation re edile bo hydrogens fela, so ra reng e bontsha re edile bo mang, hydrogenation. Reactants o swantse be alkene and H2, which is hydrogens, so that's why we say hydrogenation. The product will be a simple alkane. So running double bond like break mo, yeah, about this one and this one. Then hydrogen gels are filler more. Now everything is sorted, then it's balanced. Because that balanced, over the number of hydrogens, this on the left and the hydrogen on the right. Left go 1, 2, 3, 4, 5, 6. On the right go 1, 2, 3, 4, 5, 6. Then balanced carbons 1, 2, and here go 1, 2. So that's what we have. Right, let's check this one is number 3. Now this is another addition reaction. So on this addition reaction, let's check what we have. We have an alkene. This is an alkene here. We've got an alkene, and then now how do you see that it's an alkene? We see the double bond between the carbon atoms here. Then now we add it to hydrogen and halogen, so which is hydrohalogenation. So hydrogen and halogen group. So now are add batho ba mo lebella rodieng o ra reng swantse be H bonded to Br. Now this H bonded to Br, and then now this bond is swantse tle break him. Now I break mo rebella re o still have hydrogens carbon 1, 2, 3, 4 le ka mo ke 1, 2, 3, 4 mara lebella mareng a major products. So major products it is ke rule, we call it a Markov-Nikov's rule. Ring in simple, you know ring ar lebella the structure. If we check out this one, the structure double bond between carbon 1 and 2. So also what attached to carbon number 1, or carbon number 1. Then double bond break already total on this structure and this one. I mean, if these two very so then I have double bond value. I mean, I check between this carbon and this carbon. Ke mangana le hydrogen on this one. Ra check ra khumana carbon number 1. So the rule ring are bond alkene reactor this hydrohalogenation. Or a hydrogen o swantse a mo beng mo hydrogen ba bantši mo bonding breakileng on. So bond breakile between this one and this one. So I break between this one and this one. Roaring are checkile 1 and 2, 1 and 2. Or o na le hydrogen ba bantši or hydrogen o tlo tla ka mo mafeleletsong, and then a tla joina mo, then Br o tlo tla mo carbon number 2. The other halogen swantse a mo beng hydrogen, but the rule is that hydrogen must go to a carbon that is having a higher number of carbons, bond breaker mo yona are checking ole ngore check le bond breaker mo right. That's why BR at lemo number 2, H at lemo number 1. So that's why it's major product. Then if you write it like this, BR at mo mathomo mo le re bo na le bo hydrogen, already bo na le bo hydrogen ba ba bobedi ba. So this we call it a minor product. A minor product here. So minor products, major product is the best product. The minor products matata bad result about shumishije. That's why we prefer to use a major product. Now what is the condition for this? They are saying the reaction conditions of this type of reaction addition, we say no water. Then and then we also can say the number 2, unreactive solvent. So around sponges they dissolve re-add in this reaction. Compound. Type of reaction we said is hydrogen and halogenation, then that's why it's hydrohalogenation. Now reactions will be alkene and hydrogen atzamayele either iodine, bromine or chlorine, voucher group number 7. So that's why this group 1, 2, 3, these are the halogen groups, and then some hydrogen, that's why I say hydrohalogenation. The product will be haloalkanes. Why haloalkanes? Or I get alkane between the carbons, a single bond fair, and then now haloalkane because oral halogen group on that product. That's why I said halo and an alkanes. So we call it combined together and usually haloalkanes. Major products here they're saying H atom attaches to carbon atom already having a greater number of hydrogen atoms. So that is Markovnikov's rule. So they don't ask for definition, but you must know how to apply it. So apply one. Always check your major product and the minor product. Right, the last one for the addition reaction. What we have, we're still having our alkene here, and then now we add water, H2O. So now we must write our structure nicely. O bonded to hydrogen and hydrogen, that is H2O in structure. So it's only in this case. Then if you're adding the water to an alkene, then the reaction conditions for this that are required, we're going to need, they're saying too much water, excess water, then small amount of acid as a catalyst. Acid catalyst H2SO4 or H3SO4. This is sulfuric acid or the phosphoric acid. Now type of reaction, we call it hydration, because when we add water, pure water, or it can be lime water, but once we add water, we call it hydration, that is addition of water. And then reactions must be alkene and water. The product is going to be an alcohols. Then now the Markovnikov still applies on this one. So let's see what is happening. So that the bond will break again here between this one and this one. So when the bond breaks, requiring hydrogen will go to a carbon that is having a large number of hydrogen. That's why OH actually on this one, and then we have the major products. Then hydrogen will come to the last carbon. These two existing hydrogens. So what are hydrogen who one so then OH, then what bond on this one. Then the minor products again. The minor products, that's what we have. Maybe the minor products. So that is the type of alcohol that we can have, which is OH. That is on carbon number 1. So we check what kind of alcohol we're going to produce. So of course this one is a, if it's on the carbon number 1, is a primary alcohol, but here we have a secondary alcohol, so we prefer the major ones, right? That's what we have. For reactions of alkenes, they always undergoes an addition reaction. So these are the 4 types of addition reaction that we can have, which is the halogenation, where we add only the group number 7 people, which is normally they say chlorine and bromine. And then number 2, we have hydrogenation, where we only add hydrogens, so we must take care of the reaction conditions, which is they will ask you more often. And then number 3, we have hydrohalogenation. We add hydrogen with a halogen group, which is can be chlorine, Br, or iodine. The last one, of course, we said will be hydration, where we add water. So that's the type of addition reactions.